Okay, let's continue on with simplifying radicals. Let's see how we do here. So we're looking for a factor of 40 that's a perfect cube. Well, I know 8 works. So this is 2 cube root of 5. Now look at the next one. I'm looking for a factor of 26 that's a perfect square. Alright, what are the perfect square factors? 4, 9, 16, 25. Any of those divided into 26? None of them. So what you need to do here is not leave it blank, not do anything, but it says write each radical in simplest form. So the simplest form is to do nothing. It can't be simplified. Okay? The fourth root of 32, we're looking for a fourth root. That's a perfect, that is a factor. So what are the fourth roots? 2 to the power of 4, 16. That one looks, there it is right there. Fourth root is 2. The fourth root of 2 can't do anything with. Okay, this one's a bit different. It looks different. That 3 is not an index. That means 3 times the root of 162. So we're going to write it like this. Okay, don't get confused that 3 is not an index. It is just multiplication. Okay, so looking for a factor of 162, that's a perfect square. Okay, now you got to decide what's your strategy. You know, what I've been doing so far is listing what are the perfect squares. Well, I know it's 2 squared is 4, 3 squared is 9, 4 squared is 16, etc., etc. I get all the way to 9 squared before I see something that I recognize that looks good. 81 goes into there. Okay, so this is going to be 3 times 9 root of 2, which I can write as 27 root of 2. Okay, you guys try this one. This one's similar. This one has a negative in front. Okay, pause the video, see if you can get this correct. Okay, factor of 27, that's a perfect square. Well, 9. So this is negative 2 times 3 times root 3, which is negative 6 root 3. Okay, I've got a few more like that. Can you please spend a few minutes trying this and then put the video back on? Okay. Root 30, there are no factors of 30 that are perfect squares. So this one can't be simplified. Okay, let's try this one. We're looking for a factor of 32 that's a perfect cube. Well, perfect cubes, got it memorized. 8, 27, 64. 8 works, goes in 4 times. The cube root of 8 is 2. The cube root of 4 I cannot do. Alright, next, the fourth root. The fourth root, what's the perfect fourth roots? 2 to the power of 4 is 16. 3 to the power of 4 is 81. That's already too big, so it's got to be 16. It goes in 3 times. So this is 2 and the fourth root of 3. Okay. There's a great video here. If you need a little bit of extra help, if you need some clarification, feel free to watch that on your own time. But we're now going to simplify radicals with variables. Okay, and so this, honestly, this is actually easier because it's very clear what is a perfect square and what is not. I can see right off the bat, x squared is a perfect square. So what is the square root of x squared? Simplified, this is x. Okay, now the next one, x to the power of 5, I know that's not a perfect square. For it to be a perfect square, it has to be an even power, right? X squared is x, the root. The root of x to the 4th is x squared. The root of x to the 6th is x cubed. As long as these numbers are even, it's a perfect square. Okay? So x to the fifth is not, that means I have to factor out what is a perfect square. So I want to take out the biggest even power, and what would be left? Just x. So x to the power 4 times x to the power 1, that is x to the power 5. This first one is a perfect square. And since it's a perfect square, I can simplify it. So it looks like that. Okay, next one. 25, well, I know that is a perfect square, and x squared is a perfect square. So it's just 5x. Alright, now let's go a little crazy. So I'm going to pull out what's a perfect cube, and then we'll see what's left. Alright, is there a factor of 32 that's a perfect cube? Yes, 8. 8 times 4. Is there a factor of x to the 4 that's a perfect cube? Yes, x cubed. What's left over? An x. Is there a factor of w cubed that's a perfect cube? Yes, w cubed, and there's nothing left over. So taking the cube root of 8, I get 2. Taking the cube root of x cubed, I get x. Taking the cube root of w cubed, I get w. And what does that leave? There we go. Okay. We're going to stop there. We'll save that for the next day. This is now your homework. Exercise, I think it's 12. Exercise 12. Okay? Good luck.